Hello, it's Mrs. Delaney, and today we're going to look at metallic bonding and alloys. We're going to start as we start every lesson with a retrieval practice. So I want you to pause the video now, read through the questions, and then come back when you've answered them. Okay, so let's self-assess our work. What particles are found in ionic bonding? Oppositely charged ions. What type of bonds occur when metals combine with non-metals? That is ionic bonds. What happens to the electrons in ionic bonding? The electrons are transferred from the metal to the non-metal. What electronic structure do the ions produced by metals in group 1 and 2 and the non-metals in group 6 and 7 have? They have the electronic configuration of a noble gas, that is, a full outer shell of electrons. What is an ionic compound? An ionic compound is a giant structure or a lattice of oppositely charged ions. How are the ions held together in an ionic compound? They're held together with strong electrostatic forces of attraction between oppositely charged ions. That is, positive and negative attract each other. Okay, so our learning objective for today is to know the structure and properties of metals. Hopefully by the end of the lesson, we will be able to describe the structure of metals, be able to explain the properties of metals based upon their structure, and be able to describe the structure of an alloy and explain the use of different examples of alloys. We're going to start by looking at the 3 types of strong chemical bonding that we've met so far. So pause the video now and write down the type of bonding that you can see in the pictures and then come back when you've answered the question. Okay, so A is ionic bonding. B, simple covalent bonding, and C is giant covalent bonding. Now we're going to look at a different thing that we call metallic bonding. But in fact, metallic bonding is just how the metal is arranged inside itself. So it's not about metals bonding with another element. It's just about basically how metal particles stick together and the structure of metals. The first thing I want us to do is to write down some of the properties of metals. So pause the video now, write down what you remember about the properties of metals, and then come back when you've done it. Okay, so some of the properties of metals. Well, first of all, they're good electrical conductors. They're also good thermal conductors. They are malleable. That means that they can be hammered into a flat sheet. They're ductile, so they can be pulled and stretched into wires. And they have high melting and boiling points, especially the transition metals. So let's have a look at the structure of metals. Metals are giant structures, and they contain a regular arrangement of positive metal ions. And around those positive metal ions, you've got a sea of delocalized electrons. Those delocalized electrons, that just means that they're moved from their local position, are free to move through the whole structure. So let's think about, why do metals have high melting and boiling points? So you can pause the video now and try and think about why they have high melting and boiling points. Okay, so they have high melting and boiling points because they have strong electrostatic forces of attraction. Those forces of attraction are between the positive ions and the delocalized electrons. And because there's so many of those strong electrostatic forces of attraction, because it's a giant structure, that a lot of energy is needed to overcome the forces of attraction. Why can metals conduct electricity? So think about what it is about the structure and what do we need in order to conduct electricity. Right, metals have a sea of delocalized electrons, and those delocalized electrons, they have a charge and they're also free to move. Those are the two things you need to conduct electricity. Why can metals conduct thermal energy very well? Now, most people can describe why they can conduct electricity, but they forget why they can conduct thermal energy. So they can conduct thermal energy. Again, it's down to the electrons. Those electrons, because they're able to move, are able to carry energy from one place to another. So think about heating one end of a metal spoon, and the electrons inside the metal will carry that thermal energy through the spoon. Okay, so why are metals malleable? Well, when you apply a force to a metal, you have to look at the structure of the metal. All of the atoms are the same size. Because they're the same size, they all arrange themselves in layers. So if I apply a force to the atoms and the layers, it pushes the layers over and it changes the shape. So the layers slide over each other, and because they slide over each other, the metal will change shape and flatten. What I want you to do now is to check your knowledge on the properties of metals. I would like you to read through the questions, pause the video and answer the questions, and come back when you've answered the questions. Okay, welcome back. Let's self-assess our work. Describe the structure of a metal. So a metal is a giant structure containing a regular arrangement of positive metal ions and a sea of delocalized electrons that are free to move through the whole structure. What type of forces hold the particles together in a metal? They are electrostatic forces. So it's always electrostatic when you've got positive and negative. What are delocalized electrons? Delocalized electrons mean that electrons have no specific location. They can go backwards and forwards between one location and another. Why can metals conduct electricity? They can conduct electricity because they contain a sea of delocalized electrons that are free to move and carry a charge through the whole structure. Explain why they have high melting and boiling points. They have high melting and boiling points due to the strong electrostatic force of attraction between the positive ions and the delocalized electrons. And because it's a giant structure, there's a lot of that electrostatic forces. So therefore, a lot of energy is needed to overcome the force of attraction. Explain why metals are malleable. Metals are malleable because the atoms are held in a regular arrangement. The atoms arrange themselves in layers. Those layers can slide over each other when a large force is applied. And metals, as a result, are malleable. Okay, so now hopefully we're able to describe the structures of metals, and hopefully we're also able to explain the properties of metals in relation to their structure. So we've done our first two success criteria. So let's look at our third one. Hopefully by the end of this screencast you'll be able to describe the structure of an alloy and explain the use of different examples of alloys. So what is an alloy? An alloy is a mixture of two or more metals mixed together, or a metal and another element, like carbon. In metals, the atoms are all the same size, and the atoms are arranged in layers. Those layers can slide when a force is applied to the metal. We've already seen this. And this makes a pure metal what we call soft. Now, in an alloy, because a new metal has been added, the atoms are not all the same size. So if you look at the picture, you can see big atoms there amongst all the small ones. So they are not able to form layers, and so they will not slide when a force is applied. This makes the alloy harder than a pure metal. So pure metals are soft and alloys are hard. Okay, so what I want you to do is try and see if you can remember that using the words below. So pause the video now and try and explain why high carbon steel and stainless steel are harder than pure iron. Okay, so let's go through that answer. In a pure metal like iron, the atoms are all the same size, so they arrange themselves in layers. These layers can slide over each other when a force is applied. This makes the pure metal softer. In alloys, there are different sizes of atoms, which distort the layers. The layers cannot slide over each other when a force is applied, and this makes the alloys harder. So hopefully you were successful with that. Okay, so let's look at some examples of alloys. Now we've heard of 18 karat gold. Pure gold is 24 karat. That's 100% gold. 18 karat gold is 75% gold because of the fact that 18 divided by 24 is 3/4. So it's 3/4 gold, 75%. The rest of it is silver, copper and zinc. So what would be the benefits of using a gold alloy rather than pure gold? Pause the video now and come back when you think you've got some answers. Okay, the advantage of using a gold alloy is it reduces the cost because less gold means less of a price. It also, because it's an alloy, it's got other substances in it, the material's harder, so it's less likely to scratch. Okay, so if you're looking at this alloy, solder, what properties would you need in an alloy to make solder? So you have to think about what solder is. It's a metal used to join two different metal substances together. Okay, so you would need solder to have a low melting point, right? You want it to melt easily. You also don't want it to corrode. So solder is used to join metallic substances together. You solder them together. It's made with tin and lead with small amounts of other metals. It has a low melting point and a corrosion resistance provided by tin, which is very low in the reactivity series. So it doesn't react with things like oxygen and water. Now here we have a special alloy. Some of you may have come across it. It's called nitinol. Now if you pause the video now and copy the YouTube link, there's a video on how nitinol is used. So come back when you've watched that. Right, the properties that we would need in an alloy for a brace would be, we need it not to be able to corrode, because we do eat and drink a lot of acidic foods, so things like orange juice and tang fastics. Right, so you don't want the metal brace to react with acids and fizz in your mouth. You want it to be able to tighten and relax. So in other words, return to its original shape easily. Now, nitinol is an alloy of nickel and titanium. It is what we call a shape memory alloy. So it returns to its original shape after being deformed. It's highly resistant and it will be used in biomedical applications in the body. I think it can be used for things like joints, when it sort of returns to its original size and shape. Now, if you look here, I've put a picture of an experiment. So what I've done in picture 1 is I have deformed a paperclip made of nitinol. Okay, in the second one, I'm putting my deformed paperclip that doesn't have the shape of a paperclip in warm water. In the third picture, it's returning back to its shape because the warmth returns it back to its shape. And in the fourth picture, we've got our nitinol paperclip back again. Okay, so what I want you to do here, where I've got 6 more alloys, I want you to pause the video and read through about these alloys. And you'll need to know some of this information to answer the questions on the next set of questions checkpoint. So pause the video now. Okay, so let's answer the questions in our checkpoint. So read through the questions, pause the video, and come back when you've answered the questions. Okay, so let's self-assess our answers. What is an alloy? An alloy is a mixture of 2 or more metals or a metal and other element. Explain why pure metals are made into alloys. Well, an alloy is better than a pure metal because it's harder and it can be designed to have specific properties. Identify each of the following alloys. A mixture of iron with carbon, that is steel. A mixture of copper and zinc, that is brass. Copper and tin, that is bronze. And a mixture of iron with chromium with some nickel, nice and shiny, is stainless steel. What percentage of gold is there in 12 carat alloy? So 12 divided by 24, which is 100% gold, that comes out as 0.5. So as a percentage, that is 50%. Why are saw blades made from high carbon steel? They're made from high carbon steel because high carbon steel is harder than other steels and saws need to be very hard. So hopefully you were successful in that. Okay, so that is our final success criteria. We're now able to describe the structure of an alloy and explain the use of different examples of alloys. So thank you very much for joining the screencast, and I hope you know a little bit more about the structure and properties of metals.